All right, boys and girls, we're going to look at taking a decimal number in our dividend and dividing it by a whole number as our divisor. And so basically learning how to divide with decimals. So this is going to be new. You guys did not do this last year as fourth graders. We've already done this in math this year with whole numbers. So we've taken whole numbers divided by whole numbers, but now we're going to be taking a decimal number and then dividing it by a whole number. So one thing that you need to know about fifth grade, when you are dividing with decimals, you will always have a decimal, or you can possibly have a decimal in your dividend. You will never have a decimal in your divisor. So you can always kind of bank on it being a whole number. And so in all these examples that you're looking at on this video, all your divisors are just whole numbers. Because in fifth grade we have done 4-digit dividends divided by 2-digit divisors, that's kind of the biggest type of division problem that you would see. You're basically going to see the same thing when it comes to dividing decimals. And so we're going to go through a couple examples together. This is really easy. If you know how to divide whole numbers, then you're going to do quite well in dividing decimals. And so I'm going to look at this first problem here. This first problem is going to be 12 and 78/100 divided by 6. So probably the scariest looking part that kind of freaks out kids the most is the decimal. And so I'll always tell my students to, especially if they see that decimal, sometimes it's good just to not even think about it. Really you could see this problem as 1,278 divided by 6. It's going to be pretty much the same thing when you start solving it. And so you can either just kind of blank that part out and you can go, okay, hey, we can deal with the decimal at the end. Or what I really like to tell my students when they start these problems is just to take the decimal and move it straight up to the quotient. And so I'm going to show that here with just an arrow, and I'm going to show that, hey, if I move that straight up to the quotient, this is going to be part of my answer. And basically when that happens, I know that in my answer a decimal should be right there. And so it's kind of like this. Once that happens, you're done. Your decimal, movement is over with. You basically now are just going to step back and go, okay, hey, the decimal's taken care of. Now I just want to go and divide. So if I were to start this problem, I would start with that part about knowing what I'm dealing with here. I'm dealing with sixes, so I'm going to have to know some of my sixes in order to solve this problem. And so I would just start my solve. So my first thought would be how many groups of 6 can go into 12, or how many times 6 can go into 12, and that would be 2. And so I'm going to start with a 2 up top as part of my quotient. I'm going to go through my same division rules, just like if I were dividing whole numbers. So does McDonald's sell cheeseburgers? Basically, we're at the sell part. We're going to subtract. So we're going to subtract 12 minus 12. We're going to get 0. And then we're just going to continue to divide. I'm not going to let that decimal, mess me up. I'm basically just going to keep going through my steps. So I'm going to compare. 6 is greater than 0. I'm going to bring down the next digit, which is 7. I'm going to think to myself, okay, my next problem really is just 7 divided by 6. So how many times will 6 go into 7? That would be 1 time. 6 times 1 is 6. We're going to subtract here. We'd have 1 left over. We're going to compare. 6 is greater than 1, so I can go to my next step, which is to bring down. And so my last step here would be how many groups of 6 can I put into 18, or how many 6s can go into 18, which if you know your facts, you know that that's going to be 3. And so down at the bottom, I would have my last subtraction problem, which would give me 0. 18 minus 18 is going to give me 0. And I'm pretty much good to go here. And so now when I go back to my answer or my quotient, I could see that since I put my decimal, at the very beginning of this problem, since I moved it straight up, then pretty much I'm looking at an answer of 2 and 13/100. And really and truly, when you're doing these problems, I always tell my students to think about reasonableness. Is that a reasonable answer? And looking at the beginning, or kind of going back to the problem, this problem was 12 and 78/100 divided by 6. I really could just think, this is pretty close just to the math fact 12 divided by 6. and 12 divided by 6 is 2, so my answer should be pretty close to 2, and it was 2 and 1300ths. And so I think I'm good to go on that problem. And again, don't overthink this. This is pretty easy. If you know how to divide with whole numbers, dividing with decimal numbers really should be a breeze. There's not going to be too much difference there. All right, let's look at the second problem. This is 20 and 6/10 divided by 2. All right, first step, I'm going to take that decimal straight up into my quotient, and I'm going to leave it there. Now I just go to work. All right, can 2 go into 2? It can, one time. I'm going to write the 2 underneath. I'm going to subtract. I'm good there. I'm going to compare. I'm going to bring down. Remember, this part here could be a little bit tricky on division. You brought down a digit, and that digit is less than the divisor. And so if it's less than the divisor, you have to stop and think. If you brought something down, something has to go up. So the something that would have to go up here is a 0, because 2 times 0 is 0. And so you have to go through those steps. Again, if you skip that step and you forget about that part, your whole answer is going to be messed up. A misconception there, an error that kids will sometimes make. They'll drop that 0, they'll bring the 0 down, but then they'll also drop the 6 down. You never want to do that. Only bring down one digit at a time. And so we're going to get the 0 again, and now we can bring down the next digit, which is 6. And then you're faced with how many times 2 can go into 6, which is 3. And so we're looking at still subtracting at the end, not getting anything left over. And that's going to give us an answer of 10 and 3/10. All right, so let's just continue with a couple more examples. This next one's going to be 9 and 3500ths divided by 5. Same thing here. You're going to take the decimal straight to the top. You're going to take it to your quotient. And so you know that's the placement of your decimal. And, something to think about, and I think this would be smart. Anytime you try these problems, you want to maybe analyze or think about it first before you even start. I think it would be smart to maybe think this. I'm going to write it to the side, but if a kid was mentally thinking about this, I think this would be really smart, because you're using some estimation skills. You're using some compatible number skills when you do this. 9 and 3500ths, that's pretty close to 10. It's less than 10, but it's pretty close. And so if you were to look at this problem and think, you know what, this is almost pretty much just like 10 divided by 5, then that would be an easy answer of 2. That's just a math fact. So in my mind, I'm going, okay, you know what, if I go solve this thing, I should get an answer pretty close to 2, maybe a little bit less than 2. And so we're going to solve it. We're going to see what we get, and we're going to see if that was a pretty good estimation. All right, so 5 can't go into 9 equally, but it can go in one time. And so one group there is going to give me 5. We're going to subtract. We'll have 4 left over. We would compare and bring down. So next step is going to be how many groups of 5 can go into 43. If you know those facts, you know that's going to be 8. 8 times 5 is 40. We're going to subtract here, have 3 left over. We're going to compare and bring down one more time. And then now when I bring down that 5, those facts should really be kind of coming back into play here. You know that that's a fact that's going to go in equally. 5 can go in equally to 35 7 times. So 7 goes up top, 35 is underneath. We would subtract here, not have any remainders, but if I think about my quotient here of 1 and 8700ths, that's pretty close to 2, which is what we talked about. We said it was going to be close to 2, maybe a little bit less than 2. And so 1 and 8700ths definitely, fits that. It's a reasonable answer. And so was 2. Earlier to say it's pretty close to 2, that's really what we got. All right, this last example here really falls into that category of a 4 by 2, a 4-digit dividend and a 2-digit divisor. Even though there's a decimal with it, nothing's going to change here with our division. We're going to divide the exact same way we've done all year. And so first step, take the decimal straight up. Now we have to think about our 12s. And by 5th grade, you should start memorizing some of those 12s, so this one shouldn't be too bad. All right, let's start this thing with how many groups of 12 can go into 1. Well, 12 can't go into 1 because it's bigger. So how many 12s can go into 13? That's pretty simple. They're right by each other on the number line, so you can't I always tell kids, if they're really close on the number line, don't overthink it. It's probably just going to go in once. So 12 times 1 is 12. We're going to subtract. We'll have 1 left over. We're going to look here and compare. 12 is greater than 1, so we're good. We're going to bring down the next digit, which is a 5. 12 is going to go into 15, again, just one time. Really watch, I will say this as I'm working this problem, really watch your decimal placement and your digit placement when it comes to your quotient. Like, I'm really keeping everything nice and neat. That 1 that I just wrote up there needs to go above the 5 because technically I'm going into the 15. I'm not dealing with the 6 yet that's on the end of this number. And so really watch for that. Sometimes kids get kind of sloppy and they kind of scrunch everything together. You have to be real careful. All right, so 12 times 1 is 12. We're going to subtract from 15. We'll have 3. We're good there. We're going to compare. We're going to bring down. And then my last fact here would be how many 12s can go into 36. And if you know those 12s, that's going to be 3. 12 times 3 is exactly 36. We don't have anything left over there. So we have a quotient or an answer of 11 3/10. And so 11 3/10, I think that's a pretty reasonable answer for this problem. I could go back to math facts maybe. And if you really know your math facts, maybe you might be thinking about this. 132 divided by 12. And the reason why I'm throwing that at you is because 132 is pretty close to what we had. We had 135 6/10. But I put 132 on there because my divisor is 12. And I know that that's a multiple of 12. If I know my facts of 12, 12 times 11 gives me that 132. And so to, again, check for reasonableness, we could say, well, we ought to get an answer pretty close to 11, maybe a little bit bigger than 11. And we did. If we kind of match both of our answers here, we could say, yeah, I think that's a reasonable answer. All right, so these are some examples on how to divide decimals using what's called the standard algorithm. Again, nothing too difficult here. As long as you know how to divide, you should be fine.